Dear all, I would like to welcome you all in the lecture series of training on competitive examination. In this session, I have listed out the important equation in the area of analog and digital electronics. Before entering to the examination, I request you to go through once again. You may get the revision purpose. Moving on to some important equations of analog electronics. So first equation is Schottky diode equation. That is I is equal to I naught into e to the power EV by KT minus 1. I naught is the diode reverse saturation current. K is known as Boltzmann constant. It is 1.38 into 10 to the power minus 23 joule per degree Kelvin. And V is the voltage across the junction. If you want, you can write V is equal to KT by Q, where T is the temperature of the junction. Q you can write in terms of charge of electron. K is the Boltzmann constant. Like that you can write. So charge of one electron is equal to 1.6 into 10 to the power minus 19 coulomb. Similarly, the voltage, the gain formula, alpha DC. Alpha DC is equal to minus IC by I. If you want in terms of leakage current also, you can write alpha is equal to IC minus ICO by divided by I. ICO means leakage current. Fine. Similarly, the emitter current is the sum of base current and collector current. You can write in terms of Kirchhoff current law. If you apply Kirchhoff's current law, you can get this answer. Similarly, you can write in terms of beta also. That is 1 plus beta into IB. What is beta? Beta DC. It is another type of gain, that is IC divided by IB. That is another important formula. There is a relation between alpha and beta where people are making a lot of confusion. So no confusion, you can directly remember the formula. Beta is equal to alpha by 1 minus alpha. Or alpha is equal to beta divided by 1 plus beta. You try to study any one of the formula correctly, then you can derive easily. Fine. So this is very important. Alpha and beta, relation between alpha and beta. Similarly, the ratio of emitter current to the base current to the collector current, you can write in terms of 1 is to 1 minus alpha is to alpha. Okay, I is to IB is to IC. Fine. Next is actually some important equation from the oscillator that I will be showing you. For RC phase shift oscillator, you can use the formula cutoff frequency is equal to 0.065 divided by RC. For Colpitt's oscillator, you can calculate the frequency can be written as 1 by 2 pi into square root of LC. If I talk about the Weinbridge oscillator, you can write the cutoff frequency is equal to 1 by 2 pi into square root of R1 C1 R2 C2. Like that, you can remember the formula. Similarly, ICS, you can calculate the leakage current VC minus VC saturated divided by RC. This is actually very important for your exam point of view. For linear amplifier, for inverting, especially inverting amplifier, op-amp, we can make it as an inverting amplifier. Then the gain will be minus RF by RIN, where RF is the feedback resistance and the RIN is the input resistance. If I talk about the non-inverting amplifier, the gain can be written as 1 plus RF by RIN. Similarly, in the resolution is very important if you talk about some kind of digital electronic segment. So resolution can be written as reference voltage range divided by total number of states. Reference voltage is VR, total number of states is 2 to the power n. So these are the few equations which I have noticed that I just put up for your reference. For digital electronics, you need to know some basic Boolean first of all. So you have to apply the De Morgan's law. A dot B, the whole bar is equal to A bar plus G bar. A plus B, the whole bar is equal to A bar dot B bar. This is very important. You may get some kind of expression and you have to convert into the reduced form. Then some important relation for solving. B plus B dash is equal to 1. B plus B is equal to 1. Similarly, 1 plus B is equal to 1. B dot B is equal to 0. Like that, you have to remember. Similarly, A bar whole bar, A dash whole dash is equal to A. Next is actually the operation of XOR operation. Expression for XOR. A XOR B is equal to A B bar plus A bar B. Whenever you are solving the adder circuit, subtractor circuit, you can make use of this. So this is actually very important. So thank you for watching this video. So I'll be coming up with a similar kind of video in the next session. Thank you.